Rob's Fix-It Shop. I've been pretty lucky because, you know, this has been the summer of coronavirus, and I've been camping a lot, and because it's nice to kind of get out. Just got back from Yellowstone, which is really nice, and been up to the Boundary Waters canoe area. And one of the things that as I'm getting ready for these trips, you know, you got all these ropes, and when you cut them, especially these cheap ones, they just fray all over the place. And so a lot of times I'll take a lighter and I'll melt them, and you know, or a match or something to kind of melt the end. And I don't know, I thought it would be kind of interesting to see if I could make a thing to cut the rope that would automatically melt the ends together. And I thought that would be a really complicated way of doing a simple task. And so that's right up my alley, right? So here's what I did: is I bought this 11,000 milliwatt hour lithium ion battery, and it's got the USB charger built right into the head of the battery. So it's a little bit bigger than one of the standard 4-volt batteries like this, or 3.7 volt batteries. But I thought this would be perfect. And I also bought myself some Nichrome wire, right? So the Nichrome wire, I should be able to you know, attach to one of these batteries, and you know, it's got a low resistance initially, but as it heats up, it gets a higher resistance. So it just kind of regulates itself. Here, let me show you what I mean. It's like I've got one of those batteries just kind of hooked up, taped in place. And if I take a piece of Nichrome like this and connect it up, see how it gets red hot like that? And so when it's hot like that, I think I can take it and just cut right through a piece of rope like that, and it melts it all together. And yeah, I think that's going to work great. Let's see, where's another piece? Like here, look how terrible that end is. And this is 24 gauge. I also kind of experimented. Here, let's hook up this smaller gauge, which I think will use less current. I don't know, we'll check that in a little bit what the current usage is, but see, that heats up a lot faster. But it tends to cool a little bit more too. So it does work pretty good. That seems really sealed off. I don't know, on the bigger ones like this, this is a huge rope, but see how you have to kind of saw it across? Because it cools down in the one place. But no, it did do pretty good, I don't know. Yeah, that's great. I love that thing. Okay, so let's try this one. Oh yeah. Nice. See? So, and here, oh, see, now that got too hot. But anyway, so I think I'm not going to do a bunch of calculations on this because I can just kind of experiment and get the right values for what I'm trying to do. But so I think I'm going to what I'm going to do is, so I'm going to just, I think, 3D print something that just is really simple, just kind of something like this, like a little slingshot, you know, with a screw here and a screw here. Then the wire stretched across like this, a little switch right here, and then something to hold the battery in place like that, so that the battery can kind of clip in like that. And then I might just solder onto the ends of the battery just to keep it simple. So I think so these batteries are 11,000 milliwatt hours, right? And so that if we've got 3.7 volts times 7.5 amps, which is what that bigger wire was kind of taken. We get 3.7 times 7.5. We get about 25.9 watts. And so this thing will probably go for what? Best case 20 minutes. I doubt it, right? I mean, it seems like a lot of power, but if you could go for 8 minutes, I mean, how much rope do you need to cut? I don't know. We'll see. I think what I'll do is I'll try to get something all together, and then we'll see how long it lasts on a battery. Yeah, so I think now next step is to go up and do a little Google SketchUp. All right, so here's the part in SketchUp. And it always takes me a lot longer to do this than I had hoped. But then I brought in the slicer, and slicer makes a pretty good model out of it. So I think I'll try printing that and see how it comes out. Well, there it is. It's about my 4th try. Yeah, I mean, on one of them, these things just broke off. Took some work. Another one, this hole was too big. So, I don't know. It's just taken me a while. Well, finally, after a couple of different iterations, there's our part. And let's bring it over here. And so there's a couple things I did. I got these kind of push buttons switches, and I got them very cheap. I think it was $8 for 10, but I couldn't buy one for inexpensively, so I just bought the 8. And so then the switch will go right in here. Okay, so we've got our hole here that's going to fit our little push button switch. That goes through down here. Then I made a little hole right here that the wire can come up, attach to the battery there, and the other one can kind of run along the back. Then our battery will fit in here, but I got to sand this a little bit because there's still a little bit of a ridge from the 3D printing, a little bit of stuff there. So let's just get started. Okay, so battery, slide in like that, right? But first let me run my wires. Okay, so I'm going to put the screw in first. I made the little hole around here a little bit small for the size nut. So I'm just going to press the nut in there, and then I'll screw the okay, that's nice and tight. Yeah, I would make that hole a little bit bigger if I did it again. But it's fitting nice and tight in there. And so now we need a wire that goes through here. And I'll bring that up through here. And we'll only need that about, you know, that long, because we're just going to solder to the end of the battery. But then we need a black wire that's a little bit longer. We want the black wire to come through here. And come underneath here, right? So now we got this wire here. We can put the battery in place. And I'm going to just scuff this up a little bit. So I'm going to solder it, but we're going to have to do it quickly so we don't wreck the battery. Okay, now let's slide that in. Alright, looks pretty good. Now we just need to strip this. Okay, so I have a big soldering iron for this because I want it to be as quick as possible. And cool it off. I just spray a little alcohol on there to cool it off. I don't know, it didn't look like it's soldered very well. It's on there. Alright, that looks okay. I'm gonna say it looks great, but whatever. I just don't want to wreck the battery. So now we want to bring that up to here and a red wire over to here. We're going to want this to come up to about here. This one to come up to about here. Okay, so now I got some screws, and I think I'm just going to put these in through the top. I'm going to mount everything on the bottom. Okay, so now I'm going to take this and just put my screw in through it. Alright, well here it is. Hold the button in. Turns red hot, just like it's supposed to. Now let's try cutting some rope with it. Got a bunch of different ropes here. Let's try this one. Oh yeah, that looks pretty nice. Let's try this one. So here it is when I charge it. See the little red light there? Then it turns blue when it's all charged up. Alright, so let's try some of these different ropes. Here you can see how the problem is with it coming apart. One thing I would say is that I don't think the switch is good enough for carrying as much current. Looked like about 7 amps that we're going through here, and I bought a switch that was supposed to cover that, but yeah, these switches aren't working as good as they could. So look at that. So got the switch, I'm depressing it, nothing. Right? Then if I go like this, boom, red hot. So, I don't know. We're going to have to work on some other way to turn this on. Okay, so mysteries abound with this thing. So, I've got my switch here, right? And I push the switch, nothing happens, right? And so I thought, well, I'll just like take a jumper and put it in there. See if the switch just isn't able to carry the current, right? Nothing. And then so if I try 2 jumpers, look at that, then it gets red, right? Nothing. But somehow when I put the jumper on it, then it works. And I think what's happening is that I think this is drawing so much current that there must be the charging circuit in here must be cutting off the power. Okay, so what I really want to see here is it really just shutting off? And so if I put my amp clamp on here, right, and I have my scope, so I'm going to slow my scope down quite a bit. Then when I push the button, you can see then that as soon as we switch on, we get up to this current for a little bit, and then boom, we shut off. And so there must be a circuit in there that's shutting it off. Let's see what we're looking at here. So that's about 680 millivolts. And if I take, 680 millivolts is, if I look at my clamp here, it's 1 millivolt per 100 milliamps. And so if it's 680 millivolts, that's 6.8 amps, right? So right at about 6.8 amps, it shuts off. So let's try putting a resistor in there and see if we can keep it from shutting off. So I'm just going to tack this guy in. Okay, that's kind of a hack, but I think may help. And I think this is just a 0.2 ohm resistor. It's very small. Now let's try it. It does heat up. Right? Okay, so let's put the clamp on it. And now let's try hitting the button. And there we stay on. So I made the wire longer, which increases the resistance. It takes a little longer to get up to speed, but does do the melting trick. Pretty nice. So I guess my question now is, what do I do? I mean, do I just kind of bring this down like this so it's kind of out of the way? Or do I try to make this bigger? I don't know. I mean, this might be the solution here, is to just kind of bring this whole post down. And that might be a little more stylish too. I don't know. Well, we'll see what I come up with. Okay, so now we've got redesigned the part, and so really what I think is going to be better is I increase the distance to about 3 inches between here and here, and so that's going to naturally increase the resistance of the wire and kind of make it about as long as the wire was when I had it all kind of stretched out on that last one. And I made a couple other improvements too, like I made this inset a little bit bigger, and so yeah, so let me put this one together and see if this one works better with this longer distance here. All right, here's the moment of truth. Oh, look at that. Sweet. Yeah, so I guess it's just a matter of getting the length right so that you don't kick off this little circuit breaker inside here. Let's try it on some rope. Do, 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 do. Yeah, pretty nice. Let's try this big one. Yeah, it's looking pretty nice. Let's try this one. These are the worst. Wow, that's really nice. Well, I guess that's it for another edition of Rob's Fix-It Shop. Nala just came down here to see what was going on, and so yeah, so I just have a simple invention I wanted to make, and because I want to cut rope and I wanted to save a little time cinching the ends, so I spent about 3 days putting this together, and it really works pretty great. I did have to adjust the length of the wire to kind of match the cutoff point of the battery, but that's a fun exercise for the student. And so yeah, I mean, I think, you know, in retrospect, it would have been great to figure out what the circuit in here is, figure out what its cutout is, then figure out how many ohms this wire is, use Ohm's law to do the right amperage cutoff. I just experimented to get it, but it took me a little bit because I really went down the wrong way with the thinking the switch wasn't good enough, and the switch is fine. It's just that yeah, the switch was fine, so I really wasted a lot of time with that. So yeah, I like it. I think it's going to do the trick. And yeah, and you know, I don't know, I'll put the plan for the part, I use Google SketchUp, and I'll put that up there. I'll put the STL up there as well, and so if you want to print this yourself, you can. But I mean, it'd be super easy to make it out of a piece of wood too. I think in retrospect, that's probably would have saved me a lot of time, but just building it out of wood. But it's a hobby, I guess, so saving time isn't the idea. So if you enjoyed it, hit like and subscribe, and thanks for watching.